Hello everyone, thanks for joining us on a Saturday morning. For Miriah's case, it's Friday night. She was saying she's ready to go to bed soon. Just a quick introduction. I'm Jia from the Google Developer Relations team. And before we begin today's session, let me just briefly introduce what Google Developer Space is about. So it's a platform for developers and startups from around the region to learn and connect with one another. And as part of Google Developer Relations team, we aim to empower and connect the communities with our people, programs, network, and technologies. Today, we are super excited to once again be collaborating with Go Singapore. They are really familiar faces. You have seen them very often on our channels. So without further ado, I'll hand the time over to the organizers, Teck Chun, Stanley, Abel from Go Singapore to share more about today's speakers and sessions.
Thank you, Jiaxing. Thank you. Good morning. Go first. It's been a while since we did a Saturday morning session. I hope you had a breakfast and rise and shine. Yeah, good weather today. Right. And yes, thank you to the speakers. We have Miriah, all the way from US. It's 8 p.m. at her time, and we have Keith and Ray who will co-speak on the second topic. Right. And the first topic for today will be from Miriah. She'll be talking about using GCP and Dockers for schedule-based Go scripts. And the second talk by Keith and Ray will be on modular data cache using Go. And today we also have Gather Town. Later on during the break, we'll be in Gather Town to socialize. So hope to see all you there. And without further ado, I'll hand over the stage to Miriah to kick off today's session. Thank you. Over to you, Miriah.
Awesome. I think there we go. That's my slides. Well, good morning. Nice to talk to you. I'm Miriah. If you have never interacted with me before, I'm sorry. You've been missing out. I do quite a lot of things. And I actually, Teck Chun reached out to me a couple months ago about speaking at a meetup. We met up with me on Go for Slack. I was unavailable at that time, but we were able to arrange a time I could come speak. And I'm really glad to be able to share a little bit with you guys here today. Just to introduce myself a little bit. I mostly get my screen time these days on Twitch. I do stream mostly in Go, but I have been doing a little bit of Rust lately. I also run several meetups through a nonprofit called the Ford Foundation, which I'm a board member of. I also organize a conference. It is the Go West conference. Their logo's behind me. This is the Go West conference logo. That will be taking place later in October. It's a hybrid conference, both online and virtual. I do have 2 dogs, and you can reach out to me on Twitter or GitHub or Twitch. These slides are available on GitHub. Well, they will be at the end of the talk. I just have to merge them into master. So they will be available on GitHub at the end of the talk. So you can click on all of these links. You can come hang out with me. All of the codes on GitHub. So you'll be able to see that. So just a little bit of background. Like I said, I organize several meetups through the Forge Foundation. We have them all here on the Meetup Pro page. And we usually do about 1 a week. So I was thinking in the grand, as we're setting up websites and we're trying to be more efficient and use the internet, especially with COVID, now that we don't see each other as much. I wanted to be able to just keep a running list of these on our site. We use Hugo, so it's a static site, and I was just really wanted to just have a list of meetups just on that front page of the site. I had tried to use Meetup's API, but they locked me out. They said, no, you can't have our OAuth credentials. You'll never be able to use our API again. I tried for a year to get access to Meetup's API, and they said, no, you cannot have our access tokens. So I said, oh, okay, well, I can build a web scraper and I can just scrape the information off the page. It's publicly available website. So that's what I did. I took probably about a month of once a week Twitch streams, and we set up a web scraper that would basically call that Meetup page that I just showed you in there. It would parse the information off that file, and it would dump a list of the meetups and that attributes in Cloud Firestore. That's great. And it's wonderful. And as you can see, the data that it gave me was really nice, right? We have the name, we have a URL, it has a description, so I can have a full description. This one, unfortunately, was blank because I hadn't updated it yet, but I could have the lists of, I could have the speaker information, the description, put all of that right on the website page, and just have it automatically uploaded. Hugo has great tools for handling JSON, so it was really easy. It also allows you to put locations up there, right? So you could have your Meet link, your Zoom link, your video link, or the address just right up there. It was really nice and helpful. So yeah. And then what I decided to end up do after that, right, we have this web scraper running, is we wanted to automate it so that it would automatically get pulled and get saved. So that's what we're going to go into later. But first, I kind of just want to run through a little bit of this web scraper code, right? Just the simple Go app, right? It's a Golang based app that will pull all of this lovely JSON information off of that Meetup screen. So I'm going to go ahead and just dive right into that code. Where is, you were supposed to come up. VS Code. Oh, it's because it's not in VS Code. It's in Vim, because Vim is how I do things. So it's pretty simple. Right? Essentially, like I said, it's just a script that runs, that every time it runs, it pulls that JSON blob off of the page, parses it, and then stores it in a Cloud Firestore data store, JSON store. So it just, I have this run function that just lives right here in a main function, and it can be accessed by a port. So anytime I call this crawl port, it automatically will do the first thing. It will get the HTML attribute for that pro page. It'll then pull all of the URLs associated with that with those meetups that I have, and then it pulls the information for each of the meetups, right? So after that, we have this nice little meetup info that we just dump into Firestore. It runs pretty quickly. We can actually run it right here for you now. Pretty straightforward. If you want to dive deeper into the code, like I said, it is all on my GitHub. You can look into it. You can look into how exactly I ran that Firestore stuff, and how I scraped the page. But it's just mainly supposed to be a simple Go server that we can hit go run main.go, come on, that we can hit over an API. Go run main.go, that should be good. And then we should be able to curl, oh, not that one. Nope. Am I already using that? I bet I am. I should have checked this. There we go. We'll just kill this real quick. Like I said, we're going to be using Docker, just a Docker image later, so it should be fine. Let me make sure I can find the right curl that I want. That's a lot of the old ones. No, there it is. That's the one I want. So let's go ahead and run this. Set it up, go ahead and run. Okay, now it's listening on port 8080. And we'll adjust, right? So every time we want to trigger that web crawler, we just hit that endpoint. Oh, yes. We moved that, didn't we? I did move it. Oops. I did this on Twitch a long time ago. And I bet it is in dev. Nope, it's not there. Here's what we'll do. I have a better option. We'll just skip that. And in a minute, we'll just hit the curl on the GCP cluster. That's way better, way smarter. We'll just come back to that in a minute. Because obviously I moved some things around. But let's go ahead while we're here. We'll open up that Docker file. Because we're going to want to see this in a minute. So, back here. So, right, so we have the web scraper that runs. Unfortunately, I was not as prepared for the demo as I thought I was because it's my bedtime, I guess. But it is on Twitch, right? You can go watch the YouTube videos or the Twitch videos and see it run locally. And we will hit it again in a minute. Right, so now that I have a script, right, that I can just run and I could just get this data, I want to be able to get it every week, right? If we have one meetup a week, then I should just be able to update it after that meetup occurs and that list would be live. So if I could just run a job once every week, I would have live meetup data. So I wanted trying to figure out what the best way to do that was. In my head, I was like, you know what? I do Google Cloud stuff at work. I bet I could run a cron job on Google Cloud. That would store really easy to fire store. It would work really nice. So I went and I Googled cron jobs on Google. And it turns out there's a lot of ways to run cron jobs on GCP. Almost too many ways. There were too many options. The most common one was the App Engine cron. This was all over the place. Everyone's like, do the App Engine cron. It was in the Google documentation. It was in people's Medium blogs. It was just the most common, right? Basically, the idea is you would have something deployed to App Engine, and in the App Engine configs, you would actually configure a cron job on that. Another option, very popular, is using cloud functions, right? So you could have a function as a service that lives on Google Cloud that would run using the Google Cloud Scheduler, which is a second option or service provided by Google Cloud that is hosted, right? So the scheduler basically would keep track of your time, and when that timer runs up or the scheduler timer runs up, it would call the cloud function itself. The other option is the Cloud Run plus a scheduler. I couldn't find a logo for Cloud Run. It's a little play button, but they didn't have an updated logo for it. So Cloud Run is like functions. The difference is with Cloud Run is it's just a Docker image or a Docker container that runs on the scheduler, right? So you have a contained environment. So instead of just a function or just a script or whatever, you can actually add a little bit more complexity to that through the Docker image in that Cloud Run. And then the last one I found, which I've had to do for work, never personally, but I have done it on work, is running a Kubernetes cron job on GKE. I did not need a full Kubernetes deployment for this. I don't think I needed to use GKE. It was just one simple script, a super easy file. That seemed like way too much overhead. So I went ahead and I was like, okay, I want to use Cloud Run. It looked really easy. I could use Docker. I need more experience with I mean, I feel like everybody needs more experience with Docker, right? Like I use it at work all the time, but we always start with base images. We always start with things pre-configured. So I kind of wanted to just use Docker a little bit, use Cloud Run a little bit, test out that technology, leverage Firestore, test out that technology, and run that job using the scheduler. So I had to write a Docker file, right? So we ended up with a Docker image that looks pretty much just like this. We're using Alpine just because I like how slim Alpine is for a Linux build. We just run a directory, copy all our files on, run gomod download. We do need to make sure that the permissions get moved over. This part right here, where the copy and the chown equals root, that caught me up quite a bit, and I'll talk about that a little bit later. But that Firestore permissions, and then we build the scraper, run the scraper. It seems pretty simple. I can build that image and just have it live in the Google Cloud Registry. It's pretty simple. And that's actually, right? This is exactly what we have right here, that file. And it's pretty easy to build and to have that image. If I remember, right, you can just do a Docker build. That's a Docker stop. I forgot what that command was. I used it a lot. Oh, it's a gcloud command, right? So let's just do sgcloud and I'll remember it. The gcloud command. Oh, builds submit. That's what we got to do. So if we want to just update, and I have these, again, I'll pop, it's right here. It's right, I have it right here. I have it literally right here on the slide, but we'll go ahead and we'll run it for you. So basically what we're doing is we're taking a build and we'll submit it to the Google Cloud Registry with this tag. And that updates it on the Cloud Registry and gives it a name so that I can reference that later. And as you can see here, we just run that submit, save it, and that has the web crawler name. So I can use that web crawler name to reference it later, which is the next step, right? The next step is we want to take that cloud image and we want to add it to Cloud Run, right? So that every time we call a Cloud Run instance, that gets hit. Right? So Cloud Run, how Cloud Run works, Cloud Run has its Cloud Run API, right? Remember at the very beginning, I mentioned, let's go back here. You'll notice that we set up a server right here, right, with 2 endpoints on port 8080. We have a crawl endpoint and a health endpoint. So what the Cloud Run service does is it allows you, it exposes endpoints that you use to trigger certain actions, right? And that all is lives in that Docker image, and those endpoints are then exposed through that Cloud Run infrastructure and can be called through any set of credentials. Well, you have to use they can be public, but also through Google Cloud credentials. You can call them and they can run your stuff. So we have 2 endpoints up here that I have exposed through Cloud Run. We have the crawl endpoint that runs the crawler and the health check endpoint, which just makes sure it's alive. And just one more thing to notice about this, right? So what we're doing in this command is we're deploying our server, right, to Cloud Run using that Docker image. And so we're going to deploy that image to Cloud Run, referencing this image, and we're saying it's platform managed. I don't really, like I said, I wanted to keep it really simple. I didn't need any special configurations. I don't need to manage it. I just need to be able to access those endpoints. So let the platform handle it, let it take care of it, and run forward. And again, we need to expose these endpoints for Cloud Run to be able to work. So we have the health endpoint, we have the crawl endpoint, and that's how we trigger our Cloud Run events or builds. No, the Docker images on the Cloud Run events. I apologize. So yeah, let's go ahead. Let's just run it. Let's go ahead and have it go. I will find that for you so I don't have to click the button about 1,000 times. Cool. It was 6337. Right, so we're doing a curl to this web address. This is the public web address of my Cloud Run instance. But I do have an authorization token required for that. It uses the Google Cloud command line tool to receive that authorization through the auth client of that tool. And I'm just hitting that crawl endpoint there. So this will actually run. And it takes a little bit of a minute, not too much. But it just does a manual trigger on that instance. As we can see, it found 3 meetups. So, and that sounds about right. We have a Go meetup in August. A machine learning meetup in August, and a Kubernetes meetup in August. So that sounds about right. And then it saved those in Firestore, ran it just like I expected it to. But like I said, even though it's super easy to trigger locally, I don't necessarily want to have to go in and run this every single time. So like I said, we want to create a cron job. We want to create something that does this on a schedule automatically for me. Well, for us, for me and us and the entire situation. We'll say us. So to do that, as I mentioned earlier, we're going to use the cloud scheduler, right? So what that does is that basically keeps track of a schedule for me, right? And we'll just call the endpoint that I've set up on that certain schedule. So for this one, I have it set up. I'm just using the scheduler. I create a job that will be run over HTTP. I'm calling it test handler, and it runs every 5 minutes. It's a get method to an address using this service account. There are multiple options for doing scheduler. The 2 main ones you can do, if I remember correctly, you can do scheduler over PubSub, which is Google Cloud's event messaging bus. You can do it over gRPC or over HTTP. I love gRPC. It's literally my favorite. Whoops. But we went ahead and just went with HTTP because we had that set up. It's super easy to hit a curl, and it runs quickly. This is just an example of how to set up the scheduler. You can also set it up through the UI. And what I ended up doing was I messed around with this a little bit, and I don't have it running every 5 minutes. I did end up just doing it once a week on Monday. I think it happens at 1 a.m. or something like that. And it just hits that endpoint, runs it, dumps it into CloudStore. And it's been working for about a month. I'm doing that really well. So I just want to talk just for a second about just a couple of speed bumps, I guess, that I ran into along the way. As you could see from that last slide, we'll just go back a minute. We had to create a service account for our web crawler. And so service accounts is how GCP manages their permissions on the cloud. Basically, you create an email with a unique ID that you associate to a deployment or an instance on the cloud, whether it be in GKE or App Engine or Scheduler or Run or the functions. Each one of those has a service account with an ID and email associated to it and a set of permissions. It took me a minute to figure out all of the permissions I needed for this, right? I had to have, I didn't necessarily want my stuff, the scheduler, to have admin permissions. I didn't want it to have edit permissions. It just needed to have just the one permission to run, to trigger a run. So it took me a minute, to research all of those permissions and figure out what I wanted. It made me super grateful for the SREs that I have at work that manage all of that for me. I don't have to think about it. But it was a good thing to learn and run through and kind of remind myself of going forward. So we were able to set up one for the web crawler scheduler, right? So that the scheduler did have permission to call that run instance, and then they authenticated through the IAM permissions. Click. The next one was Firebase. I thought that I could just magically get Firebase to also follow service accounts. I literally enabled every single service account, and I just couldn't figure it out. And there probably was a way to do it. But what I ended up doing was something that you saw previously in that Docker file. Locally, I had the Firestore creds, right? My Firestore creds for my Firestore project, I had been running locally. I had not ever tried to do the Google Cloud, the G Cloud auth when I was adding to Firestore locally. I had always just done permissions through a JSON file that has my private key and etc. And so after trying to figure it out, I decided that the easiest thing to do was just add that key to the Docker image, which is one of the reasons why I'm super glad I was able to just put it on a Docker image and throw it up there and not have to stress or worry too much about having the right permissions and getting Firestore to work right. And I was at the point where I was giving my scheduler, not the cloud build, but, well, I was giving the cloud build and the scheduler both Firestore admin permissions, and that just didn't seem right to me. But I was able to just add this file, and that just gave it the ability to upload right quick and not have any issues. The next thing is trying to find the logs on GCP. I am so used to just dealing with standard out when I'm doing small projects or working on my own, especially on Twitch. I don't really do a whole, I did this whole project on live stream, and it took me a long time to figure out if my stuff was running, how it worked, what it was doing. I mean, how to query the logger stuff. And I was trying to run it, like trigger it on the cloud too, right? Turns out the easiest thing for me to do was, one, create an endpoint just like this one, but that just said health, right? It was a lot easier for me to do this than it was for me to go look at the logs. And all this does is it tells me what's there, and says we're alive. So it lists all of the files in there, tells me we're alive. I know I can hit it, and I'm working where. And I was able to put all of that back into my standard out and not have to go do a separate query on a log. And then just having the things up here, right, to check, also still printing in my standard out instead of running that curl. I was able to figure out that Google Logger and check failures. But for me personally, it's still kind of foreign. I really don't like looking at logs. I don't like loggers. I always prefer to debug over standard out. Obviously, there's more experience that needs to be gained there. And that last roadblock that I have listed on the slides is having the endpoints exposed. I didn't even think at the beginning about having a health endpoint up that I could just hit and make sure that my deploy ran or that it was deployed. But as soon I had a friend who had been also using the Cloud Run say, why don't you just add a health endpoint? And I was like, oh, well, that's dumb. Kubernetes does that all the time. They have that's super basic, right? Having that health endpoint. And that was really able to help me get it started, get that little bit of confidence, know that my stuff was running and that it worked really well. My watch was Siri was running on my watch. It was recording this whole talk. Guess that's how Apple's going to learn all about GCP. So yeah. So just in summary, I know this was a little quick, but I would love just if you have any questions to shoot them my way. Really quick, it was like if I wasn't doing it on live stream and trying to maintain all of that, it would have been super easy. It was really straightforward, building that Go app, adding it to Docker, uploading that Docker image to GCP, and then running it, right? It was really easy to do in Go. It was really easy to upload. It was really nice to have that container, right? Where I knew where all my files were, especially because I did add that permissions JSON file. Just to know that I had that container there. Everything was self-contained and running and accessible. And the G-Cloud app made it really easy to create the schedule, to run it, and to, deploy. I didn't go into a couple of things here. I know I didn't do a super deep dive into the web crawler because I feel like, first of all, if you want to do a decent web scraper, you probably should use a more DOM-friendly language. Even JavaScript, I know I don't tend to recommend JavaScript, but you can use JavaScript for that. And I also didn't go much into Firestore, just because I think I have a friend who's given a really good talk on that. And I think it's an entirely separate topic that could take an hour or two just to go into and explain, and to talk about really thoroughly. But running that simple Go script on the cloud with Cloud Run and Scheduler, it's really nice. It runs every week. It's been running for 2 months, and I don't even remember it anymore. It doesn't email me when it fails. It doesn't have any major issues. So I do have a link to that Firestore video at the end, as well as a link to any streams I had while I was going through this and testing it and debugging. Feel free to catch up with me on Twitch, on Twitter, or on YouTube. I am on those weekly, if not daily. That's where I do most of my Go. Most of my stuff is experimental. It's me learning how to be a better developer, and messing with tools I don't use. So you're not going to get a whole lot of best practices. You're going to get just mostly hacky stuff. But it's super fun, and it's a really good way to learn. And that's pretty much what I've got for you today.
Thank you so much, Miriah, for the talk. That was quite interesting. Yeah, I think we already got some question coming in from the YouTube stream. Right, let me pull it up here. The first question from Sirin. So he was wondering if putting your creds.json inside the Docker is the best way to do it.
No, the best way to do it definitely would have been with your IAM permissions, right? But like I said, it's like I wasn't like after I didn't want to spend too much time on it, and after a 2-hour stream, I couldn't figure it out. I decided to just not worry about it. I do have the video that my friend did on Firestore, which I do have on the next slide, so you can get it on the GitHub. He did it with the IAM permissions, which is fine. But all of the information I was storing was publicly available. There's nothing sensitive in it, and there's really nothing to like hack. So I was not too worried about the best practices in this endpoint, right? I don't have personal information. It's just the stuff that was available on that public endpoint. So I was just kind of like, it works. And, it's on GCP, and there is at least the minor authorization, bearer auth, that does have to take place to call it. So it's a little bit minimal, not best practice, but it worked for this.
Well, yeah. Is your image on GCP as well? Because that means the image is protected. Your image, your Docker image.
Yes, the Docker image. Yes, everything on GCP is encrypted while it's hosted. Yes, so like there is basic security around it, for sure, right? Like it wasn't the worst thing to do, but at the same time, it's also not the best thing to do.
Definitely. It's more like an MVP, right?
Yeah.
Right. Yeah, we got another question from Syrian. So why did you choose to run a HTTP service and not simply a HTTP client script and save?
Mostly because I wanted to play with the tools, right? Like a lot of this reason that I designed the things it's the personal projects I choose and the way I build them is because I want to play with new technologies that I don't get to use much at work. I do a lot of GCP at work. I don't do a lot of HTTP at work. GRPC, excuse me. I do a lot of gRPC at work. I do a lot of NSQ. I do a lot of messaging and event stuff. I don't do a lot of HTTP. I've probably written 5 HTTP endpoint clients and 1 server in like 3 years. So stuff you need to do. I also wanted to mess with Firestore, and I really wanted to see how to run this cron job. And so HTTP and that stack was the best way for me to kind of use that skill set and learn that technology. If I was doing this for work, for like real production with real stuff, I probably would have done it very differently. But for learning, it was super nice.
Interesting. Yeah. Following up on that, actually, I saw that you mentioned, you've been using a lot of gRPC at work, and it's better for production environment. But I'm wondering, like, what are the trade-offs between choosing HTTP versus gRPC for your internal microservices?
Just in general, personally, the reason why I would choose gRPC over HTTP is for the protobufs, for having that defined message format that's serialized, very small, which allows it to be done quicker. You're forced to have a schema. They're backwards compatible. The stuff that comes with protobuf, right? gRPC is just an RPC over HTTP2. So like on the back end, it doesn't save you much. But in the development and the fact that you are stuck in certain rigidities with the protobuf, it makes it really nice to communicate between teams and also scale across multiple services with those defined messaging contracts.
Yeah, makes sense. It's a bit chaotic if you only use HTTP.
Yeah. Yes. A little. Sometimes.
All right, let's switch it up a bit. So, how much does it cost you to run these GCP cron jobs?
Well, it runs once a week. And I don't know the conversion rate. I don't know if you guys know the conversion rate, but I have not been billed I haven't even hit $5 yet. There is, I believe, with some of there are quite a few things available on the GCP free tier, right? Like the Firestore stuff that I'm running is all free because it's hasn't hit a certain threshold. And I believe Cloud Run lets you run like 100 times per month before it costs you anything. So I think I only have to pay for my Docker image storage. So it's very minimal what I'm paying. Like it hasn't even been $5 a month. I know a lot of people, when they start doing personal stuff on the cloud, they'll get huge bills and it kind of builds up fast. But I've been fortunate, right, in choosing the things that are on the free tier, right? That's probably another reason why I went with Cloud Run over Cloud Functions. Cloud Functions don't really have a free tier, while Cloud Run does have that. Oh, you can run X number of times before you have to pay. And that's, allows you to flex a skill without incurring a whole lot of pain in your pocketbook.
Yeah, that's why we all end up with the free tier skills.
Yes, free tier.
For the while, yeah. I've been using free stuff as well. Never pay a single dollar except for my domains.
Yeah.
All right, let's see what else we have in the chat. Okay, yeah, we have someone came in and broadcasting about Shiba Inu and some other crypto coins. Yeah, maybe we can use these free stuff for mining cryptos.
Yeah, I think that's why they have a limit, right? You can only run X number of times, or else the people trying to mine their crypto are gonna abuse the system, right?
Yeah.
So just only, I don't know how much you would get after 100 runs. Probably not worth your time.
Yeah.
But
exactly. But yeah, hopefully we don't get too many of those. Then we're gonna be out of option for free tier.
Yeah, we need keep the free tier.
Yeah. Hinting at Google.
Yes.
Cool. All right, let's give another couple of minutes and see if we have any further questions in the chat. If not, then we are gonna go for a quick break soon. So, Miriah, if it's not too late for you, please join us over in gather.town for some socializing as well. I think that some of the audience would have more questions, but they're just shy to post in the
for sure.
stream, I guess.
I'll be there.
Yeah. So, yeah, I don't think there is any further question from the stream. So I'm just gonna drop an announcement message here. Yeah. So we are gonna go for a 15-minute break, and socialize over in gather.town before we start again for the next talk from Keith and Ray. So yeah, guys, please join us over there. Gonna flash the CFP. All right. Hey folks, so we are back with Keith and Ray. So yeah, Keith and Ray will be sharing about their e-commerce cash design. Oops. All right, so I'm gonna leave it to Keith and Ray to start their sharing. Give me a moment. Hey Ray and Keith, you wanna start talking?
No, so
sorry, I didn't give you a cue. Sorry. Yeah, go ahead.
Is everyone seeing the slides?
Yep.
Okay, hi, I'm Ray. So just to give you guys some backstory, I was from F&B. So I ran my own restaurant. And after COVID hit, I took up a JavaScript React bootcamp. And from there, I got pretty interested in coding and moved over to GoSchool, which was mentioned earlier in the chat. And now I'm actually doing blockchain development in a startup, primarily focusing on launching their own assets and trying to integrate it into their existing infrastructure using a mixture of Go and JavaScript. I'll pass time to Keith to give you guys some backstory about himself.
Yeah, sure. So like Ray, I'm a career switcher. So as I mentioned on the other time just now, a year ago, right, I'm about, I'm slightly over 2 years out of college. For 1.5 of those years, I was working as an investment banker, advising on mergers and acquisitions across Southeast Asia with the UK firm Barclays. Decided it wasn't really for me. And I guess, I always had that curiosity about the mindset and the tool set of engineers. So I made the decision to leave that job and start a bootcamp in Go. So that was when Ray and I met. What we're going to present on is actually our kind of capstone project from that bootcamp, just to consolidate everything that we had learned. I think for me, it's kind of it was kind of my first attempt working collaboratively and doing something slightly more involved. I know in the grand scheme of things, it's still a relatively small project, but so I think after completing that bootcamp, I since found so today I'm a trainee software engineer at a robotics company. Looking forward to learning the full stack of the technologies across hardware and software. But so right now I'm actually spending a lot of time writing JavaScript as I learn more about the front end of my current company. So that's a bit about myself. Thank you.
Okay, so I'll take over and talk about the project. So as Keith mentioned, we were like relatively greenhorns. So we wanted to kind of like understand more about the technologies. So first thing we wanted to achieve from this project was we wanted to avoid depending too much on external packages. The idea where you keep importing or installing from GitHub, and when it suddenly doesn't support a certain functionality you need, then you are kind of dead. You have to find a new one, or you probably have to build it on your own. And since we were given 3 weeks, we just wanted to just spend the time developing something from scratch. So this is the approach that we took. Hearing from like some of my friends that are currently working right now, pair programming is actually a very popular approach taken. So I think for those that are in Singapore, you probably would know of GovTech and DBS. So they do take a pair programming approach where like one person codes and the other one's just like watching. Fortunately for me and Keith, we were actually both quite agreeable. We could actually iron out things and work together quite well. I've heard some horror stories from some of my friends also where someone just pushes out all the code and then the other guy has to fix all the problems and stuff like that. So it was quite fortunate for us. I would say it was quite an enjoyable experience. We did something like a morning and afternoon shift, so each person takes turn to actually code. we went with test-driven development, since that's kind of like the rave at the moment. We spent a lot of time thinking about our code structure and systems design, and a lot on the caching approach because it's an e-commerce site. And we went with a read-through and write-through functionality for that. Then we thought about how we're supposed to implement payment through Stripe. Okay. So this is the software structure. Essentially, we split, because it's Go development, right? And we didn't want to use JavaScript because it's a GoSchool course, you see. So we actually had to use a form of templates to actually render on the browser. And we split the template logic from the application logic, and the application logic from the cache manager logic. So what really happens is when the browser actually requests data from the server, the application will actually request it from the cache. And if it's not found in the cache will actually get it from the database. And when the browser sends any data in form of post to the application, the application will update the data in the cache manager, and the cache manager would then save it into the database. So this whole design consideration was actually due to the fact of we researched a lot into kind of e-commerce sites, and usually when you kind of scale really big, you kind of need to actually cache a certain amount of information that people have requested before, or else you're going to spend too much time reading and writing if you're actually going to reading and writing from the database, if you actually have to do it on every single request from your users actually. So now I'll actually pass the time to Keith, where he'll talk more about the database schema.
Okay, great. So database. I think our database was a fairly kind of simple one because, I mean, again, this is not the main point of the project. The basic idea here is that we used, we had this orders table that would reference, through foreign keys, the other tables, which, then would return various details about merchants, products, and users. Yeah, so I think it's fairly simple, and I don't think we have to spend too much time on this. I think we can talk more about sort of the schematic, and the way we lay out our caching package. So okay, I'll start with the app, right? So this app package is what actually gets run when you hit run main.go. It consists of a pointer to a router, so just an HTTPS router. We used Gorilla Maps for this project. A pointer to a cache manager, which is where we'll be spending the most of our time, and a blacklist, which essentially is just it just contains a list of endpoints that we want to let we feed into our middleware so that the middleware only conditionally acts on certain endpoints. Basically, we used this middleware to ensure that certain operations were only available to verify, or authenticate the users. So, okay, so just quickly on the DB package, because basically the database itself is just kind of a pointer to a MySQL DB. And then after that, these are just the data types that are being passed around for you to know. So they're all encapsulated as structs. So essentially, the product would be identified by a unique identifier, and then we have name. So name of the product, quantity, and then we have string referencing a thumbnail, price, product description, and then linking, and then a product ID linking this particular product to this particular merchant's inventory, and then a simple integer counter to keep track of sales. Yeah, so I think that's kind of what we have to keep in mind. Okay, so for the caching package, I guess we'll start with the cache manager because this is what our application package gets, right? So the cache manager basically consists of two primary caches, other than so there's a pointer to a database here, which I guess is part of our read-through, write-through setup. I can talk a bit more about that later on. But for now, we can just focus on the active user cache as well as the item cache. So we've got two caches active here, okay? Each of them essentially have embedded a cache type, right? So this cache type, right, is essentially a map, okay, where the key is a string, containing the identifier of the object, and then the value is a cache object. So a cache object is an interface which implements these three methods: monitor, update expiry time, and get key. Get key allows us to reference a particular object, whereas monitor and update expiry time essentially work hand in hand in order to let us automatically expire items that get added into the respective caches, right? So we have one cache. So we have one cache that manages user sessions and one cache that manages item sessions. So item session is essentially just cached sort of popular items. I can think of it that way. And they're both implemented the same way, and yet they keep track of different types of data. And we achieve that by implementing the cache object interface. So what is in the cache object interface? So as discussed earlier, right, we've got these three methods. Types that implement this particular interface, right? We've got the first one that we've got that implements this particular interface is the cache item type, right? So it primarily logs information about a particular item, right? You see there pointed to a DB product. And then it logs, and then it also embeds the type expiry, which keeps track of when this particular item should be removed from the cache. And then the other type that implements the cache object interface is itself an interface, right? So this is called active session. And active session essentially so the types that implement the active session interface essentially are merchant sessions and user sessions. So the key difference between the two is just that with user sessions, you have to keep track of a card. That's it. And notice that cache items and cache user sessions, they all implement this expiry type, which basically automatically so it kind of self-refreshes and self-regulates in that there is an embedded timer that is tracked concurrently, and basically upon the expiry of this timer, the cache object will remove itself from the relevant cache. Right. So okay, this just illustrates what I discussed earlier, that user session further implements a type to keep track of the card, what they have stored in their session. Okay, so this is kind of a bigger picture. I hope it's not too small, but if you like, we can spend say 10 seconds on this. We welcome any questions or comments about the layout of our cache manager, because as we mentioned earlier, this is kind of a project for us to kind of test out what we've learned, and we'd be very glad to kind of get more out of it from more experienced perspectives. Okay, so more about the cache manager's behavior and layout. So here are some of the principles, right? So basically we want the cache manager to be all the app is aware of. So the app doesn't have to worry about the DB structure and directly make calls to the DB. I think basically what we're keeping in mind here is that we want to make it more. We think that this makes the whole project more maintainable. So and also I guess given that most of the calls that we're expecting will be read calls as opposed to write calls, we think that having the case where the app references first the cache, and then for the cache to update itself against the DB where necessary, basically a read-through, write-through schema, would be the one that made the most sense. The way we've set up the cache manager itself is basically that as much as possible, we try to keep data fields unexported and allow access to them using methods that were defined on the interfaces, methods that were defined on the data types that were then made public, and basically the app would be able to interface with the cache manager through those methods. Okay, so I touched on this briefly earlier, but basically, we'll see this in the next slide. But we've set it up. So the way we've set up the cache object is such that every time a cache object gets added to the manager, we also concurrently launch a kind of, I guess an observer, right, that would terminate the session upon the expiry of a certain timer, and auto refreshes the object, if it gets accessed again. So this is kind of just keeping sessions alive in memory. And I guess because we implemented the cache object interface, right, we were then using this particular, we were basically using operations on the cache manager in a polymorphic way. And in order to do this, we needed to do some type assertion on the cache object, on the elements contained within the respective caches. So we'll see an example of this now. Right, so I would like to direct your attention to the right side of the screen first on the function get. Right, so the arguments of get are key, which references a particular object, object type, which basically is a statement of whether. So okay, sorry, I actually think that so again, right, this is kind of right. I think if we were going to write this again, we would have probably wrote it differently. I think in this case, right, we don't have to worry about the object type argument. A database just basically contains a reference to the database. So what we do here is we check if a particular key exists within the cache. So if it doesn't exist, we do some, we parse the key a little bit to determine if it's a user session or if it's an item session. So if it's a user session, that's the first two cases, right? If it's you, it's a user session. If it's M, it's a merchant, it's a user session. So if it's either of those cases, then we say that, right, this particular session does not exist, right, within the cache, and you have to sign in again because your session has expired. So if it's not a user session, that means it's an item, right? So that means that some user is trying to access an item from the cache. The item doesn't exist in the cache, so we add that item to the cache from the database. So notice that after we call add item from DB, right, we retrieve the item from the DB, and then we add it into the cache through, right, the map syntax. You see that? And then after that, we concurrently launch the tidy function, right? So the tidy function, what it basically does is it calls monitor which refreshes the expiry on the cache object, or it simply returns, so when it returns, then tidy would proceed on to delete, which would then remove the particular key from the relevant cache. Right, so that's what happens if an item is not found within a particular cache. Well, if it is found, right, then we go into the else block of the get function, in which case we simply say, right, okay, this item was accessed again. So we refresh the timer on that particular cache object and we continue. Yeah, so that's kind of, right, a little bit about how we used how we used Go to set up a modular data cache. I think something that, so here are a couple of things that we didn't quite go into. I think these are some of the things that we thought about, but ultimately we didn't want to spend too much time on them because it wasn't necessarily the project to kind of come up with a super optimized cache in this case. I mean, after all, we did this in like 2.5 weeks. So I think I think some things I will further note about this cache is that it is mostly a first in first out cache, which we thought was a reasonable. I'm sure it's optimizable, but we thought this was a reasonable approach to do it. So first in first out because basically whenever the item doesn't exist, it gets added to the cache with an expiry. Right, it's mostly first in first out, but basically with the asterisk that if the item is very popular and gets repeatedly revisited, then the expiry gets repeatedly refreshed, right? Then in that case, it's not quite first in first. I guess something else that we would have paid a bit more attention to if we, were to visit it again, probably would be avoiding data races. I think, I guess thinking about it now, I think we did give some thought to transactions, using transactions on the database. We did give some thought to, Okay, yeah, so we did give some thought to the transactions, but I guess we'd be interested to hear more about whether you have whether we'd be able to get any other opinions from you. All right, so I think that's all we have. Yeah, we welcome any questions and comments.
Oh, thanks for the talk, Keith. So we have a few questions coming up here. So one from Tony Milton. Do you need some? Okay, thanks. So any reason you wanted to hide the access to the DB from the app by putting the cache and the middle as proxy? Sounds like the cache is responsible for more than just caching.
Can you guys hear me?
Yep.
Yeah, there's actually a very good reason for that. It's because of our application structure. So the application will actually process data that it receives from the cache manager. So if you have any errors in terms of representing your UI components, it's actually in the application. But in the cache manager itself, we then segregate it from the cache manager and a database kind of struct, because the database struct would then house all the queries to the database. So if you do have database errors, you kind of know which file to pinpoint it to straight away. So it's more for maintainability. That's why we actually went with that approach.
Okay, there's a follow-up from Tony. So he's a fan of the repository pattern, but injecting a cache into that, so it'll only fetch from DB if it's not found in the cache. So he sort of, I think, supports the idea. Yeah. Okay. Do you have any okay, he replied thanks also. Okay, so anybody else have any questions? Okay. So if there are any more questions, you can also continue in Gather Town. So thank you for everyone to join us on this Saturday. We know it's like a weekend for everyone, and coming here is also like from your time. Oh, we have one question from Stanley. Yay! Actually, Stanley, you can come in and ask. So I'll read it out for Stanley. Do you do performance tests on the cache? And what was the improvement?
I mean, okay, well, no, we didn't do. We didn't do performance testing on the cache. I think, yeah, basically, I think we had, again, a limited amount of time to implement this project, and we were really trying to get it to work. Yeah, so I wouldn't be able to answer the question directly. I think we had some ideas that we didn't get to implement. I mean, one of them was definitely to do performance testing. I think on the topic of performance, we will say that, right, like it made us a bit nervous, right, using type assertion in this way to figure out whether, to figure out the relevant operation to call. Because we are aware that type assertion, carries an overhead. So I guess another sort of setup that we were exploring, that we would have considered and might have implemented, was to store the objects using a tree data structure instead, like a trie, TRIE, and then relying on the fact that we'll be able to access any one of those objects, like we'll be able to access different locuses of that trie by calling specific string patterns on the object names. Yeah, I think that was something that we would have considered as well to further improve performance. Yeah, but I guess I'm not sure what. I do look forward to kind of doing performance testing, in some, with not on this project, then maybe on another one. Like I'm currently, 7 months. It's been 7 months since I wrote my first line of code, and I'm not sure how long it's been for Ray. Right, so I think this is definitely something that I'd be very keen to learn more about.
I'm sure. Sorry. I'm sure you'll learn a lot more because I think performance testing on its own in Go is like a whole new dimension to learn on, of stuff to learn on. You're continuing, Ray?
No, I was
About
gonna
your
point out,
experience?
like, if other people actually want to implement a cache manager, there are also some other things that they might want to do. First is you might actually want to use channels to actually control your race conditions, because it's actually slightly more performant if you actually try to scale it. There are some benchmarks that people have run using channels versus mutexes. On top of that, there's actually one big flaw in our project, which is that we didn't kind of set a limit to the number of items that can be stored in the cache manager. So this thing could actually be done if you actually use the counter, so you don't kind of like flood your cache manager with a lot of unnecessary things. And you can also use certain measures to kind of tidy up highly accessed items, but these were all due to time constraints. We didn't have time to implement it in about 2 weeks.
Okay, we have more questions coming up actually. One from our resident speaker, Siwin. So did you reference and try and build on what they call group cache?
Sorry, what does group cache mean? Because
actually,
it's kind of foreign to me.
Group cache is a Golang. Okay, so I guess the answer to that question is no, because if you guys are asking this question, it's a no. But basically, group cache is something from the Golang library to come up with caching based on Go. But maybe we can look into it next time. It's an open source project, as Siwin said later. But I would guess the answer from both of them is a no if they just heard of this. So do you have a follow-up question, Siwin? Or if not, we'll just go with the next question first. So there's one from.
I will add that I did. We haven't seen this project, and I think I'd be interested to look into it. But I guess a kind of key sort of motivation for us as well, right, is to as much as possible just like try and come up with something from scratch. I mean, I get that it's not like this is not how you want to approach kind of writing things that people will actually use. But I guess this is more of a kind of tinkering project. We'll definitely look into group cache as well. Thank you.
Yep, that's good. Okay, so I really do agree with Kamal. You guys really did a very good job for coming up with your own cache and everything. So on to the next question from Dicky. So he's wondering if the goal tidy statement will cause a memory leak if there are many key values to store and the expiry time is very long, because the monitor function will sleep until the expiry.
So I don't think this would be an issue. So I think so. What it seems like to me, Dicky is saying is that every time every time we refresh the timer, we add a certain duration to the timer, which then potentially leads to some arbitrarily long, right, or infinite, effectively infinite timer on the expiry. I think what we're doing now is actually refreshing the timer back to say, let's say a session life is 30 minutes, right? We're saying that if within the next 30 minutes the item gets hit again, we set it back to 30 minutes from 15 minutes in. So it's a refreshing timer, not an append. It's not an append, it's a replace. So I think the session life is always 30 minutes. Yeah, I think that's how we're addressing this worry. We did run into this consideration while trying to write this. Do you have anything to add, Ray?
No, that's actually about it.
Okay, so maybe wait around a minute more for any more questions coming in. If not, I'll do the wrap up. Yep, Dicky got your explanations. He said thanks. Okay, so thank you everyone for coming and listening to our talk on a Saturday. And thank you to our speakers, Miriah, who has already left because it's at night in her location, and to Keith and Ray for giving this very insightful thought on caches. Most of us will be just using caches and we never really think about it, right? So this presentation will help us look into the more interesting aspects of how to implement a cache. Of course, Golang is always looking for speakers. So if you guys would like to speak and come to our future meetups, please feel free to send us a message on Meetup. Then we will schedule a talk for you. And also, if you guys are not in Gather Town yet, please feel free to join Gather Town. And we'll be just hanging around Gather Town for a while. There's no limit to the Gather Town, so you can stay as long as you want and chat as long as you want. Our speakers, Keith and Ray, will also be there, right? So they'll join us. Yeah. Sorry?
Yeah, I'll be there for a bit.
Yeah. We'll just hang around for a while and we can have a chat over there. So thank you all everyone again for coming, and see you all in Gather Town. Bye.